In this lesson, we're looking at the chain rule. So the chain rule is a differentiation rule that occurs when we have a function within a function. So if we have something along the lines of f of g of x, then that chain rule will apply. And because we're only looking at polynomials this term, it means that we're looking at situations where we have some function raised to a power n. Now we can have a constant in there as well. So the rule that we will be using will be that the derivative of the function, so function y in this case with respect to x, will be derivative of the inside multiplied by derivative of the outside. So this is derivative of the inside, and this will be derivative of the outside. We could also look at that as derivative of the internal function multiplied by the derivative of the external function. Okay, so now that we know that, while I'm going through the examples, I'll talk about terminology. Okay, the first example, we'll look at y is equal to 3x take 5 to the power of 4. Okay, so our first step is that we have to identify the internal function. And that internal function, we just let it equal u. Okay, so the internal function for us is always going to be that function that's within the brackets. Okay, so that means that u is going to be 3x take 5. And so now we can state what the external function is. So the external function will be that y is equal to 2u to the power of 4. So 2u to the power of 4. So since we let that 3x take 5 be u, we replace it in that function as well. Okay. So the next step is that we want to find the derivative of each of those functions. So to find our derivatives. Now because this is u with respect to x, then it's going to be du dx. So u with the variable x du dx, and the derivative of that will be 3, and 0, so just 3. And this function here will be y with the variable u, so it's going to be dy du. So it will be 8 u to the power of 3. So multiply by the power and take one away from the power just as normal. Now, it's 8u to the power of 3, but what's u actually equal to? As u is equal to 3x take 5, it means it's 8 3x take 5 to the power of 3. Okay, so we've got our du dx, we've got our dy du, so our derivative of the function at the start is y with respect to x, which means we get dy dx will be equal to du dx multiplied by dy du. Dy dx will be 3 multiplied by 8 3x take 5 to the power of 3. So our derivative, dy dx, or y dash, will be equal to 24 3x take 5 to the power of 3. There we have it, there's our derivative. Now I'll do another one just so you can see how it works when we have a slightly different set of variables. So e.g. 2 r is equal to negative 6 3n squared take 4 to the power of 11. Okay, so we're going to follow the same idea, and we can let u equal whatever's in the middle. So in this case it's going to be 3n squared take 4. So 3n squared take 4. We'll replace 3n squared take 4 with u, so r will be negative 6 u to the power of 11. du dn, so u and n, will be equal to 6n, and the derivative of 4 is 0, and dr du will be equal to 11 times negative 6, which is negative 66, u to the power of 10, 11 take 1 is 10, and as u is equal to 3n squared take 4, it's negative 66, 3n squared take 4 to the power of 10. Now it's always going to be the product of these two, but we want to make sure we communicate it properly. So we start off with r with respect to n is going to be our derivative. So dr dn. The easiest way to work out what we're going to do is to split up this dr and dn. Alright? So dr dn. dr stays on top, dn stays on the bottom, and we fill in the other two spots with du. So there we have it. We've got our dr du, we've got our du dn, so it's the right values. We just now need to sub them in. So negative 66, 3n squared, take 4 to the power of 10 times by 6n. Now we can't actually combine anything except for the 66 and 6. So 66 times 6 is so negative 396 n. Then our 3n squared, take 4, all to the power of 10. That's our dr dn, or it could be our r dash if we wanted to as well. So there we have our derivative again. So just be aware that the chain rule can be changed to fit the variables in question. Right. So we'll have another slight little change, and now we'll look at what happens if we have a fraction involved. So y is equal to 5 on 6x take 3 to the power of 4. Okay, so we can't actually, and this is similar to our last lesson when we had our fraction, we need to be able to move this entire bracket up. Remember our index laws. So remember that x to the power of negative 1 is equal to 1 on x in reverse. So we can move that up, and it's still y because we're not finding the derivative yet. We'll move this bracket up, and it'll be 6x take 3, and instead of being a power of positive 4, it'll be negative 4. So now we have that, we can just apply our chain rule. So u will be equal to our internal function, 6x take 3, and therefore y will be equal to 5u to the negative 4. du dx, so u with respect to x, will be 6, and dy du, we multiply by negative 4, so we get negative 20, u to the power of negative 4 take away 1, which is negative 5. Now, as u is equal to 6x take 3, we get negative 20, 6x take 3 to the power of negative 5. And we can move that down, we get negative 20 on 6x take 3 to the power of 5. So that's our dy du. So now we have to join them back together, and remember it will just be the product, but we want to communicate it. We're looking for y with respect to x. So dy dx is equal to, now we split these two up, dy dx, and we fill in the remainers with du. So dy du, which is negative 20 on 6x take 3 to the power of 5, and multiplied by 6, we can think of that as 6 on 1. Gives us negative 120 on 6x take 3 to the power of 5. There we have it. Y dash, or dy dx, is equal to negative 20 over 6x take 3 to the power of 5. So remember, this is only for very specific scenarios that we're talking about at the moment, when we have a function of a function. So it means that we have a function raised to a power. Alright, I'm going to look at one last example, and this is going to involve our square roots, our rational indices. So it won't be your favourite thing, but it is definitely something you need to learn. So let's look at y is equal to square root of 2x plus 9. Right, now the first step is the manipulation again. So we have to recall that square root of x is equal to x to the power of a half. And we're going to apply that here. So that means it's going to be 2x plus 9 to the power of a half. Now, because it's in the right form, we can apply our chain rule. So we can let u equal 2x plus 9, and therefore y will be u to the power of a half. du dx will be 2, and dy du will be 1/2 u, and when you take 1 away from 1/2 we get negative 1/2. Now we know as u is equal to 2x plus 9, we get 1/2 2x plus 9 to the negative 1/2. But we want to have a positive power, so we have to move that down, so it becomes, it joins a 2 on the bottom, so it becomes 1 on 2, 2x plus 9 to the power of 1/2. And we should recall that power of a half means square root. So it will be 1 over 2 square root of 2x plus 9. That's our dy du. So now, again, dy dx is what we're looking at from our original y with respect to x. Break that up so we get dy and dx, and we fill in the remaining spots with du. So it will be dy du, which is 1 on 2 square root of 2x plus 9 multiplied by 2, and we can treat that as 2 on 1. So that will become 2 on 2 square root 2x plus 9. Common factor here, so this comes down to 1. And our final answer, dy dx, will be 1 on square root of 2x plus 9. Okay, so that's upping the complexity. That's getting pretty hard. Still, it should be something you should be able to comfortably do. You need to be able to do square roots, and you should be starting to get used to that process now. And those chain rules, as you can see, are relatively straightforward. We're always following that same pattern. Okay, so that covers the chain rule. We will learn a shortcut chain rule that we'll use in further questions when we start combining the chain rule with product and quotient questions. But we're not going to do that today. We're going to leave it right there. Okay, so make sure you've taken notes. Make sure you understand the chain rule. Particularly make sure you remember that relationship that dy dx is equal to du dx multiplied by dy du, and how we split that up to make it easier for ourselves, and you will be fine.